So probability is success out of total. Any probability you have can never be over 1. There's never, if you look at a die, could you have a probability of 0? Yeah. If I'm trying to roll a 7 with one die, there's a 0 out of 6 chance of getting that. Can I get a probability of 100%? 6 out of 6, sure. So the boundaries for probability, which we're going to see a lot, are going to be 0 to 1. You can never have less than, there's no negative probability. And you can never be over 1. If you have over 1, you did something wrong. Because the success out of the total, you can't have more successes than there are total. This term here causes a lot of grief when we look at tomorrow's independent. Mutually exclusive, I mean, if you talk about dating, it's pretty easy to tell, but mutually exclusive just means there's no intersection. No intersection. If you wanted to, you could say the probability of A intersect B, this is intersect, is equal to 0. And this guy here is an intersect. You remember this? And this is a union. Kind of weird. I think you guys were the first group in Honors Pre-Calc that we did a little review of this at the beginning of the year in Honors Pre-Calc, and we did some of these Venn diagrams that you're going to do in a little bit. IB plays with these a lot, but let's talk about mutually exclusive. So if we're looking at the union of A and B, the union of A and B is just the probability of A happening plus the probability of B. And it's like, what's the probability of rolling? A 2 or a 3? Well, 2 is 1 out of 6. 3 is 1 out of 6. And we add those together, you get 2 out of 6. Is it possible to roll a 2-3? No, there's no such thing as a 2-3. So there's no intersection here, so we can add these up. But most of the time, the probability of A union B, most of the time, it's going to be the probability of A plus the probability of B minus the probability of the intersection. And you're kind of going, oh, that's kind of complicated. But it's not if you look at a Venn diagram. If this is A and this is B, okay, the union is this part in here. It's this total in A or in B. That's the union. You okay with that? So if we took A and then we took B, you're going to be counting part of this twice, aren't you? This black part is going to be counted twice. So you don't want to count it twice. You want to count it once. So you subtract the intersections so that you only count it once. Is that all right? You'll use this a lot tomorrow, maybe even today. All right, so Venn diagrams. It's a visual way of looking at intersection and union and two groups and probabilities. All of the probabilities are going to add up to 1. So the sum of all the probabilities are going to add up to 1.0. That's what we should have. Okay, so we're going to get that to happen. And then we're going to take a look at this one, and it says for the events A and B, the probability of A is 0.6. So if I put a 0.6 in here, I'm talking about all of this here is 0.6. And if I say the probability of B is 0.7, I'm saying all of this is 0.7. Well, what's the problem with this? What's the problem with that? 0.6 and 0.7. Well, they don't add up to 1. That's a problem. And there's this overlap here, isn't there? So let's do a couple of things. First thing, it says that the union of these, that means everything in these two bubbles, including that intersection, has to add up to 0.9. So here goes. probability of A plus the probability of B minus the probability of A intersect B should be equal to the union of A and B. That's what it should be. So we said the probability of A is 0.6. Probability of B is 0.7. Now that's way too much. Okay, but I want to find out what that intersection is. The total is going to be 0.9. Okay, so then if you have 0.6 plus 0.7 is 1.3 minus 0.9 should be equal to the probability of A intersect B. The part we really, really, really want to know is what's in the middle here. And that's going to be 1.3 minus 0.9. That's going to be what? Huh? 0.4. There you go. So that's good news. So now we know the intersection part is 0.4, and A is 0.6, so that's going to make this 0.2. B is 0.7, that's going to make this 0.3. Now, if this is all 0.9, how much is out here? 0.1. So now you have everything set up to answer these questions. You okay? Kind of makes sense. Kind of cool. All right, so let's look at what they're saying here. In part A, probability of A intersect B. Well, we figured that, 0.4. Okay? Here, probability of A intersect, not B. Yeah, well, not B is going to be 0.2, 0.1. That's what not B is. We're going to intersect it with A. So A is the yellow part, which is circled purple and in a yellow bubble. It's in the yellow bubble. 0.4, 0.2 are in the yellow bubble, but it has to intersect, that's A, it has to intersect not B, so that's going to be 0.1 and 0.2. So the intersection is going to be 0.2, right? Did I lose anybody? Okay, you try B and D without my help. Good luck. So using the Venn diagram, we can do one like D here, which says not A, and that's this 0.1 and 0.3. That's not A. And then B is going to have 0.3, but we're only going to count it once, and 0.4. So that gives us 0.8. That's Venn diagram. Then the last one, we're going to do a couple of problems here having to do with probabilities and also groups. So let's go down to this bottom one here. A family of 3 children. List the sample space for 3 boys. So there's three possibilities. What are the chances of having the first one be a boy? 1/2. What are the chances of the second one being a boy? 1/2. Third one being a boy? 1/2. So you might be kind of swayed to just put 1/8. And it is 1/8. 1 out of 8 chance. But you kind of are going, well, won't all the probabilities be 1/8? Yeah, they will. But what are they? So you could have a boy, 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 a boy, girl, boy, a boy, boy, girl, and a girl, boy, boy. You could have a, let's see, yeah, boy, boy, girl. Oh, did I mess this up? Yes, I did. Girl, girl, boy. Girl, girl, boy. You could have a girl, boy, girl, and you could have a boy, girl, girl. What else could we have? Like my uncle, 4 girls. 3 in this case, yeah. Right. Anybody know any families that have all boys or all girls? Yeah, how many boys or girls? Oh, you have all girls in your family. Do you consider yourself lucky?
Yeah, we also have 2 girl dogs.
Really? That's interesting. Your poor dad. No, he's lucky. Okay, so this is what kind of makes you think. there's a total of 8 of these, and if we kind of think this through, each of these are going to be 1/8 chance of happening, each one. So if each one of them is 1/8, right? What are the chances of 2 boys and a girl? So how many of these have 2 boys and a girl? Well, the first one doesn't, second one does, third and fourth one do. So that's going to be 2 boys and 1 girl. 3 of those, 3/8. At least 2 girls. Okay, so at least 2 girls will be here, 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 and here. That's at least 2 girls. So that'll be 4/8 or 1/2. So zip up to the top one. Committee of 4 are selected from 7 men and 7 women. How many ways can this be done? To give you a little bit of notation, when we're looking at groups, we talk about combination, N, R. So sometimes we'll go 7, choose 3. Okay? And another way to write that is like a vector, 7, choose 3. I like this way the best, just as long as you remember it is going to be a group or combination. Okay? But that's going to help us for the next part. A committee of 4 is selected from 7 men and 7 women. How many ways can this be done without restrictions? So there's 4 slots. How many people are there total? 13. So it'll be 13, then it'll be 12, then it'll be 11, then it'll be 10. So this is going to be 13 permutation 4, or 13. No, it isn't. You're right. It's a combination. Over 4 factorial over 9 factorial. Thank you. It's a group. You're right. Then it says there's an equal number of men and an equal number of women. So when we're looking at the probability, you could have, of the 7 men, there could be 2 of them. And of the 6 women, there could be 2 of them. Of the 13 people, there could be how many? 4. So that would be the setup for equal number of men and equal number of women. If you want to, you could go 7 choose 2 times 6 choose 2 over 13 choose 2. It's a good way to show it. You use your calculator or other means to figure that out. You try this C. See what ideas people have. Hold that thought. Mm-hmm.
What I thought is that you could do like 7 choose 1 times 6 choose 3, and then have that parentheses plus 7 choose 2 times 6 choose 2, times that parentheses, and then plus 7 choose 3 times 6 choose 1 parentheses, and then all over 13.
And then one more.
Well, I thought it was supposed to be all over 13 choose 4.
Right. All over 13 choose 4, because you're having 4 in the committee. So this has 1 male, 2 males, 3 males, 1 female, 2 female, 3. That fits it perfectly. Did anybody do it a little differently? Yeah.
I did all possible ways of 13 choose 4 minus 2 times the combination 7 choose 4 because you can't choose all males and you can't choose all.
So minus 7 choose 4, and that would be 6 choose 0, right? I'm wondering if you want to just maybe do minus this, minus 7 choose 0, 6 choose 4. Because I don't think these will be equal. But you're in the right track. You're in the right track. So both of these are great. And then this here takes care of everything, doesn't it? Or is this is not a probability, so I don't think yeah, so it's not a probability. This one shouldn't be a probability then. So both of these should be the same. And if you're wondering how to do that with your calculator, I can show you that real quick. Make sure you're thinking groups or arrangements. Groups would be C. So 13, choose 4. Okay, so 13, math, probability. 3, choose 4. And that's that familiar notation that we looked at. 7, 15. Now what's 6, choose 0 going to be? 6 factorial over 6 factorial over 0 factorial is going to be 1, isn't it? So it's going to essentially be 7, choose 4. 3. Which is 35. And 6, choose 4. I can do that in my head. That's going to be 30 over 2. It should be 15. 6, math, probability. What was that? 3, 4. Should be 15. Yep. So this is going to be 665, right? And then you can check this one and see if it equals 665.